Okay, this is video number 2 for integrated 1 to go along with the exponential growth worksheet. Make sure that you complete these problems throughout the video as I'm going through this, and then do the you try problems afterwards. Okay, video number 2 specifically focuses on being able to write an exponential equation given a table, graph, or a situation. So if we take a look at this, we'll take a look at question number 2. Exponential equation that models the given table. All right, if we take a look at this, we're going to need a couple of things. We need to figure out what the multiplier is. So in this case, we know that everything here is going to be exponential, which means it's repeated multiplication. So I'm going to choose two values that are consecutive, or one right after the other. And I'm going to write an equation. So I know that 10.5 times something. I don't know what that something is. That's what I'm trying to find. That's our multiplier. It has to give me the next number in the list. So I'm going to write a small equation for this. So 10.5 times, since there's decimals, I'm going to use parentheses here for the multiplication, times b is going to give me 7.875, the next number in the list. What I'm going to do is I'm going to divide by the 10.5 to get it off of the b and to get the b isolated. So I know those are going to simplify. So now at this point, I'm going to go ahead and grab my calculator and I'm going to type this in. So I'm going to do 7.875 divided by 10.5. That's going to give me 0.75. That is the multiplier. That is the number that goes from one to the next. What you can do in your calculator is actually check and make sure that times by 0.75 works to get us the next one, which it will. So we've got the multiplier. That's good. We still have to find the 0th term. Well, we can find that in the table. Now, if we multiply to go down in the table, we're going to divide to go backwards in the table. So to find the 0th term, I am going to take the 10.5 and I'm going to divide it by my b value. 10.5 divided by the 0.75 that we just found. So if we do that, that's going to give us 14. Okay, there's our 0th term. That's going to be a in our equation. So now from here, we should be able to write it. So y equals, remember the general form is a b to the x. So y equals 0th term, 14, b, 0.75 to the x power. And that's our answer. All right, moving on to question number 3. I want to talk about a situation. So we have Trina raises geese. She started with 2 geese. All right, starting with, this tells us that's our 0th term. So A is going to be equal to 2. That multiply by, okay, there we go. We're being told how this is growing. So our B is going to be 3. All right, reproduction continues at this rate. All right, let's see if we can write the equation. So y equals a times b to the x, same equation we used a minute ago. Y equals, plug in a, plug in b. Do not plug anything in for x until you're asked to do that. That's the next part of this. If reproduction continues at this rate, how many geese will she have after 5 months? All right, we want to make sure this is all in terms of months. So it said they multiplied per month, and we want to do 5 months. So it looks like we're going to plug in 5 for x. So I'm going to take my equation, 2 times 3, plug in a 5 for x. And when we do that, we'll type it into the calculator. That's going to give us 486, and we are talking about geese. Now, be careful. If for some reason you got a decimal here, you want to make sure that you round appropriately. Any decimal or fraction of a goose technically counts as a whole goose. So make sure that you round up for this. Okay, so now some more stuff with graphing. It goes back to the stuff that we did previously, but I want to make sure that we can do some quick recognition. So if we take a look at our equations here, the quick recognition I'm looking for are my pieces. So if my a value is 1/3. That means my y-intercept is going to be 0, 1/3. Not necessarily a point that I would typically graph. So I go, okay, well, let me take a look at the growth. Take a look at the number inside. Notice that your b value is bigger than 1. because 4 is bigger than 1. I know this is going to be exponential growth. So what I'm looking for is I'm looking for a graph that grows. Take a look at the right-hand side. We know that a growth graph starts low and then goes high. So if I take a look at my options, all right, the only one that it could be is the second one here that I am now highlighting in yellow. It's the only one it could be out of the two. Let's make sure it actually makes sense though. So if I take a look, my y-intercept, yeah, is somewhere between 0 and 1. That's good. I also see that the graph looks like it is growing. I am going to say that this graph goes with this equation. So those guys go together. All right, let's take a look at the other one. You can see my y-intercept is going to be at 0, 4. Okay, I feel better about that y-intercept. If I take a look at the value inside, this b value is between 0 and 1, which means I expect exponential decay. And then looking at the side, I also know that decay starts high and then goes low. All right, let's take a look at the graph. Take a look at the graph. My y-intercept is at 4. That's good. And then my graph should start high and go low, which it is. So if I highlight this guy in orange, that one is definitely going to match with the second one.